as we think about writing our own questions, I want to give you some frameworks for writing what I think are good exam questions. It looks like this. It presents learning as a multicolored triangle hierarchy, different categories. The mistake, though, that people think, well, I don't need the other levels. I can just, create constantly. No, if you tell someone you're a mathematician and you don't know the quadratic formula, they're not going to believe. But just remembering the quadratic formula, you determine whether or not, like, should I use the quadratic formula here? Should I use the quadratic formula here? Should I use the quadratic formula? And recognizing, okay, I can use the quadratic formula immediately here. It would be totally wrong to use the quadratic formula here. And I can use the quadratic formula here if I first rewrite it so it's in the form ax squared plus bxe plus equals 0. Sort of like the next level. You don't just have the quadratic formula in your head walking around with it. Can you actually do the quadratic formula? Can you use the quadratic formula and come up with the numerical answer? So do you know which of these are A, B, and C? Can you now analyze? Next is draw connections among ideas. So maybe you then learn completing the square or factoring as another method. And can you look at problems and say, what are the advantages of using the quadratic formula compared to factoring? What are the advantages of using the quadratic formula compared to completing the square? And this is a way of thinking about it. Now, for exam questions in math, it's very easy if you're not careful to just group everything down here, to make everything be similar questions, to make everything be based on a formula. And I think that when the exam is well done, it has a hierarchy. It has the entire hierarchy. So you do have some questions that ask people to remember the formulas and use them, but you also have some that ask them to do creative thinking. And so our goal here is to hit the entire hierarchy.